If you've done the first assignment from Unit 6, 6.1a, you may have noticed something about all of the systems of equations as you were going through and solving. There was something about those equations, so let's go back here and take a look at what we did yesterday. And I mentioned at the end of yesterday's discussion, you'll notice that each one of these was set up so it would be easy to graph. They were all in slope-intercept form. They were all solved for y, so it was fairly easy to just go ahead and, graph the equations, find the point where the lines cross, and then write down the answer. So today we're going to pick up right where we left off. We're going to be talking about solving systems of equations by graphing. So go ahead and write that in the I can statement right there. And today they're going to look a little bit different. We're going to do 3 problems here. We are going to get a couple of unique answers, but to start off with, you'll notice that this equation right here, the red equation that we've got to graph, is not in slope-intercept form. If it's not in slope-intercept form, we've got to get it there because that's the only format that we've studied where we can graph that linear equation. So here's what we're going to do. We're going to get y by itself on one side because remember, this is our goal, y equals mx plus b. So I'm going to move the 3x to the other side. So I'm going to do that by subtracting 3x. And then I'm going to come over here. Okay, so I've got some space to work that. So I've got a negative 2y on this side. I'm going to write the negative 3x first, and then I'm going to write the minus 4 over here. Make sure I got all the signs right. I did. Okay, now I just need to get the y by itself, so I'm going to divide every term on both sides by negative 2. Remember, that's kind of that little shortcut we took to get to the right format. So y equals, this would be a negative divided by a negative, so this is 3 halves x. Negative divided by a negative is a positive, so that's going to be positive 2. And this right here is the equation we're going to graph. Now, if this were a test question, and I absolutely guarantee you're going to have something like this, you're going to get some points if you can just write that in slope-intercept form and be ready to graph it. So we can tell you know what you're doing, you know what the goal is here. Let's go ahead and take a look at the blue one. We're going to do the same type of thing. I'm going to get rid of the x by subtracting x. That's going to leave me with a 2y on this side, a negative x minus 4 over here, and then we're going to divide by 2. So that's going to give me a y equals, and then again we're going to slide that coefficient out front with a fraction. So this is going to be negative 1 half x, and then this is going to be minus 2. So what we've got here is a little bit of extra work compared to yesterday. We have to put them both in slope-intercept form, so we want to be very careful doing that, because if we're not graphing the right lines, we're definitely not going to get the right solution. So let's go ahead and graph the red one. This one crosses at 2, so crosses at 2 on the y-axis. The slope is 3 halves, so we're going to rise 3 and run 2. Rise 3 and run 2. Pretty steep in the positive direction. Going the other way, we're going to go down 3 and back 2, down 3 and back 2, down 3 and back 2. And again, if you've got quite a few points here, you can make a nice straight line. Make it as good as you possibly can. This is why it was important to get in the habit of extending the line off the graph, because you never know where these points are going to cross. You want to make sure you've got enough of the line that you can tell where they're going to intersect. So let's graph the next one. This one crosses at negative 2, and the slope is negative 1 half. So that means we're going to go down 1 and right 2. So we're going to slope gently down in the negative direction. Up 1 and back 2, up 1 and back 2, and you probably can see what the answer is right now. But I've got enough of the points here. I can go ahead and, even if I draw a little bit of a crooked line there, they cross right at this point right here. So we're going to go ahead and write down the point. Again, we're going to write it down as an ordered pair. I'm going to put a big fat dot right there, and this would be back 2. So the x would be negative 2 and the y would be negative 1. Okay? So there's the solution right there. So today's assignment compared to yesterday's assignment is one adjustment. You've got to make sure that you put them in slope-intercept form so they're in a format where you know how to graph them. Okay, so that's problem number 2. And again, at any point if you think, I think I got this figured out, if you want to just pause this or fast forward it and work ahead or something like that, that's totally fine with me. Just make sure you're getting these right. So let's do the red one. Again, I'm going to move the x to the other side. And again, if you want to think ahead and think, gosh, what are we going to do with the next step? Think about what I'm going to write here. We're going to write the x first. Make sure that's a plus 4. Then we're going to go through and divide everything by negative 2. Think about what that's going to do over here. Think about what we're going to get right here. We'd have a positive 1 half x. There's our coefficient. There's our slope right there. And this is a negative 2. Again, we'd get points just for getting that far if this were a test question. So we want to make sure everybody knows we know that's the line that we're going to graph for the red one. Let's do this one. All right. We're going to write down the 8y. We're going to write down the 4x and negative 16. Okay. And then we're going to go through and we're going to divide everything by 8. So we're going to be careful as we do this. We end up with a y over here. This would cancel. This would reduce to be the fraction 1/2. And then this would be a negative 2. So I'm going to go ahead and put a dotted circle around that. And then we're going to do the red one first. So this one needs to cross at negative 2. And it's got a slope of 1/2. So we're going to rise 1 and run 2, rise 1 and run 2. Again, we want to follow that stair-step pattern so that it's really clear we know what we're doing, and so we can draw that nice straight line. Forgive my little line right there. Okay, extended to each end. And then we're going to look at the blue one. Now take a look at the blue one. This one crosses at negative 2. That's interesting. Hey, wait a minute, look at this. The slope is positive 1/2, so we would rise 1 and run 2, rise 1 and run 2. That means that this blue line is going to be right on top of the red one. Now, if the blue one is a picture of all the points that work in the blue equation, and the red line is a picture of all the points that work in the red equation, we want a solution that works in both of them. We want point or points that work in both of them. Now, we ran into a problem yesterday where the lines went like this. They were parallel. They didn't cross each other at all. And in that case, it was no solution. Okay? That is not what this is. If they never touch each other, if they never intersect, that's going to be no solution. But on this one, this is a whole bunch of points right on top of all of those other points. So every single point that works in the red one would work in the blue one and vice versa. So think about what that would mean. That would mean that there would be infinitely many solutions. All right, and if we wanted to be really specific, we could say anything that works in the first one works in the second one. So anything where, and I'm just going to write it like this so we don't have any fractions, anything that works in this one would work in the other one. So any point that makes that equation true would make both of them true. Okay. All right, let's take a look at this last one right here. This is number 12 from your assignment. And again, I would really encourage you to pause this, work ahead, see if you can get these right. If you can, you've really got this figured out. This is a great skill, a great introduction to being able to solve systems of equations. So I'm going to go ahead and do the red one. We're going to add 6x. 9y equals 6x plus 27. We're going to divide every term on both sides. To be fair, we're going to divide every term by 9. This reduces. 3 goes in there twice. 3 goes in here 3 times. And 27 and 9, I'm hoping we've dealt with those numbers enough. We know that that goes in there 3 times. So that's what we're going to graph for this one. And to make sure nobody thinks there's a negative on there, I'm just going to make it look like that. And then this one right here is kind of interesting. Take a look. This is y equals, if we move this over, we get y equals 5. So a very quick one to come up with the equation and then graph. I'm going to stick with blue here, y equals 5. So that's going to be, remember, a horizontal line. It tells us which axis it crosses. It crosses the y-axis at 5. If it were x equals 5, then it would be a vertical line. And then the red one looks like this. It crosses at 3, positive 3, and the slope is 2/3. So we're going to rise 2 and run 3, and there we are right there. Now I'm just going to do one more over here and one more over here because I know we've got that point where they cross. We're just going to make this look good. I'm going to put a big fat dot right there, and notice what we've got. That point is over 3 and up 5. Shouldn't be any surprise because 5 is the only y value that would make this equation true. You could even plug it in right here. 5 minus 5 would be 0. That one better be 5, then we just needed to find the other one. Okay, great practice here with solving systems of equations. We've already done a couple from your assignment. Good luck getting the rest of them done.